first sum is if vectors E1, E2, E3 form an orthogonal basis. Orthogonal basis. We must understand what is orthogonal basis. Forms an orthogonal basis of three-dimensional real space R cube. It consists of all real numbers, three-dimensional. Then the vector mu, u, you put the mu, okay. Mu or u equal to 4, 3 minus 3 belongs to R cube. It is also real space, belongs to R cube, can be expressed as. So u can be expressed in terms of this orthogonal basis. First, what is basis? Orthogonal basis we have to see. The basis means it is the basic element required to represent something. Basis, that is basis. Yes, we are suppose we are telling the dimension of room is x, y, z, like that. Dimension of room, x is length, breadth, and height. It means we know that x, y, z are mutually perpendicular. That's why we are telling that x, y, z. If they are not mutually perpendicular, we won't say in terms of x, y, z. If three variables are three bases, the bases are mutually perpendicular, then they are independent. X is independent of y and z is independent of y. All are mutually independent. If you take x and y, independent. X and z, they are not dependent. Each independent variable because they are orthogonal. Orthogonal means the phase angle between the two is 90 degree. Whether it may be a signal or it may be a whatever it may be. If the phase shift between the two variables is 90 degree, then they are called orthogonal. If you see, this is x, y, and z. If you take these two are 90 degree. If you take these two are 90 degree. These two are 90 degree. Any two, if you consider between them, the 90 degree is there. That's why they are independent. If any change in x will not affect y, if any change in y will not affect z because of this 90 degree. Orthogonal. Orthogonal means 90 degree. So this forms this x1, e1, e2, and e3 forms an orthogonal. The same type of. It is not unique. The basis is not unique. Isis, it is like this, and it is like this. It is like this. So 90 degree, here it is 90 degree, here also it is 90 degree. So I am taking this E1, E2, E3, different basis, that's all. If I use these bases, then it is not in terms of, I can say 5x plus 4y plus 3z. I cannot say like that. Instead, what I have to tell, 5e1 plus it may not be 4 because this is different domain, this is different domain. Let us assume same coefficient plus 3e3. So like that we can say this way. So the e1, e2, e3 also three bases which are mutually perpendicular, that we understood. So here these three bases are represented in terms of our conventional basis. In conventional basis, E1 is 1 time x and 2 times z. So we can draw like this. So this is E1. Its magnitude is unity. Its magnitude is E1. And E2 is taken along y. And this is E2. E3 is forming by -2 in the x direction. So -2. And in z direction 1. So this much. Okay, you can put you can draw parallel to this and parallel to this. This is parallel to this. So this is, and this is E3. So if you see that, if you by trigonometry we can prove that this angle is 90 degree. This angle is 90 degree. That's why they said it is orthogonal basis. Angle between E1 and E3 is angle between E1 and E3 equal to 90 degree. You can very well prove that because its length is 2, it is 1. Therefore, this angle is tan inverse of 2 by 1. That is tan inverse of 2. This angle is opposite side is 1, adjacent is 2. Therefore, tan inverse of 1. If you add these two, definitely this is equal to 90 degree. This is in the ground plane because x and z are in the ground. This is also in the ground. Therefore, E2 is automatically perpendicular to E1 and E3. E1 and E3 also perpendicular. That's why this E1, E2, E3 forms a basis, he said. Its length is unity. Its length is unity. So here it is not unity, but let us assume unity. This is -2. This length is -2. So by using this basis, a vector is represented 4, 3, -3. U equal to 4, 3, -3. If you represent in terms of, this is represented in conventional x, y, z, it is mentioned. If you represent in E1, E2, E3, what is the vector? He's asking. That we have to find. Now let us find that. Let's assume that U equal to x1 x1 E1 plus x2 E2 plus x3 E3. That is equal to x1 E1 equal to 1, 0, 2, 1, 0, 2 plus x2 that is y0, 1, 1, 0 plus x3 multiplied by E3 equal to what? -2, -2, 0, 1. Therefore, we can write what is U? U equal to this. This is also equal to 4, 3, -3. 3, -3. Therefore, if you take this 4 equal to x1 plus minus 2x3, 3 equal to x2 and -3 equal to 2x1 plus x3. So how I wrote this? This represents the three bases of conventional basis. Therefore, x1, x2, x3 are sorry, x, y, z, x, y, z, whose magnitude is given, that should be multiplied with the corresponding value. So you got 4 equal to this x equal to x1 of x, here 0, here -2. Therefore, x1 minus 2x3 you got, that is equal to 4. So you got 3 equation. From this, what we got is x2 equal to 3 already we got. x2 equal to 3 we got. Now, if we these two are in terms x1, x3. So if you multiply this by 2, let it be 1, equation 1, 2, and 3. Multiply 1 by 2. Equation 1 is multiplied by 2. You will get 8 equal to 2x1 minus 4x3. So if you add, subtract this equation, subtract this from this, what you will get is -3 minus 8 minus 11 equal to 0. You will get plus 5x3. Therefore, x3 equal to, this implies that x3 equal to 11 by 5. x3 also we got. Now we have to find x2, substitute x1, substitute this 11 by 3. 11 by 3 in place of x3, you will get -3 equal to 2 times x1 plus x3 minus 11 by 5. 11 by 5. So what you will get? -3 plus 11 by 5 equal to 2x1, or minus 15 plus 11 by 5 equal to 2x. This implies mm, minus 4 by 5 minus 4 by 10 equal to x1. Mm. The u equal to mm, x1 e1. x1 equal to how much? Minus 4 by 11. 4 by 11 e1. X2 equal to how much? 3. 3 e2 plus minus 11 by 5 e3.
Sir, it's minus 2 by 5, sir. 4 by 10, sir.
Oh, okay. Very good. So minus 2 by 5 e1 plus 3 e2 minus 11 by 11 by 5 e3. So u equal. So this is the answer, which is correct. Okay, D is the answer. I think. Yes, D is the answer. But here it is printed, both are correct. Yeah, let us put a plus sign so that it will be wrong.